see examples to justify that. Differentiate. So, if you have to consider this example, you realize that the first one has to do with sum throughout, then the second one has to do with sum and product. So, what we do simply here is, let's say this is our y, this is our y. So, if you have to differentiate this, we have our y to be equal to 3x squared plus 5x plus 7. So we have dy dx because we are differentiating y with respect to x, and that is how to write the notation. Then you have to differentiate this with respect to this. But first and foremost, it should be noted that if y is equal to x raised to power n, dy dx is equal to nxn minus 1, and this is the differentiation formula anytime, any day. Each time you have to differentiate, this is the formula you have to apply, and that is what we have to apply here. So here we have, what are we doing? 2 times 3, then we subtract 1 from this. So 2 times 3, that gives 6. So x squared minus 1. I have differentiated this plus this. Remember that when you have x, is x raised to power 1, but that one is invisible. So I have put that one as invisible, so it can be visible to me. So you have 1 times 5, you have 5. X raised to power 1 minus 1. This 7 we are looking at, it is 7x raised to power 0, but because by law of indices, anything raised to power 0 in this world becomes 1, and 1 times 7 gives you 7. That means this 7 has x raised to power 0, but because the power of this variable does not favor its appearance, that is why you are not saying it there. So what it means is that 0 times 7, that is 0 minus this. So automatically, what you are having here, when you differentiate a constant, it will definitely give you 0. That is very, very important. dx of c, where c is equal to a constant, you have 0. Take note of that. So anytime you have a constant, if you differentiate a constant, you're going to get 0. So differentiate this constant, you have 0. So plus 0. So this one becomes 2 minus 1, 2. 2 minus 1, 1. So you have 6x. 1 minus 1, 0. 0 raised to power, x raised to power 0, 1. So 1 times 5 plus 5. So therefore, dy dx will definitely be equal to 6x plus 5. And that is the answer to this first one, which is the sum. Then the second case. The second case also followed the same trend, where you have y equals to 7x cubed minus 5x squared plus 6x minus 7. So what we are, 3 times 7, that's 21. So dy dx is equals 3 times 7, 21, x cubed minus 1. Remember, each time you multiply, you subtract 1 from it. Then the second one, minus 2 times 5, 10, x squared minus 1. This one has a 1 as a power. 1 times 6 plus 6. 1 minus 1 is 0, so the x will no longer be there. And I said that when you differentiate a constant, you have 0. So you have a scenario like this. Then you have dy dx to be equal to 21x squared minus 10 x, and that is minus 10x plus 6. And this is the answer to the B part. So these are the simple examples justifying how to differentiate. And in this scenario, you are differentiating your y with respect to x in both cases. The next subtopic here is the function of function. It's another important concept in differentiation. Another name for function of function is the function of functions, is the one that is called chain rule. If you don't want to call it function of function, then you call it chain rule. What do we really understand by function of function? If you have y equals to 2x plus 5, this is never a function of function. If you ask to differentiate it, you just say dy dx gives 2 as your result. But a scenario whereby you have y equals to 2x plus 5 raised to power 5, how do you differentiate this? You know there is no other way to differentiate this rather than resolving it by using the function of function method. And if you have to differentiate this by function of function, what do we do? If you are given this in an exam to differentiate, and you are dealing with, and you have limited time, there is a way you can differentiate this without going through the function of function. But if it is theory, you have no other method rather than resolving it by using function of function. What we do is you bring this one to this side and subtract 1. You bring this one to this side, subtract 1 from it, then you differentiate the inside. What am I saying? If I bring this one to this side, I have 2x plus 5. This 5 is still here. This 5 I brought here, I will now subtract 1 from it. Then I differentiate the inside. When I differentiate the content of the bracket, then I have to put the 2 here. Then you have 2 times 5, that gives you 10. And 2x plus 5. 5 minus 1, 4. So that means dy dx is equal to this. That is a short method of doing it. But it is not acceptable in theory, because there it is required, it is expected of you to follow the concept of using chain rule or function of function to solve this. This is a short method. Maybe you are dealing with multiple choice or multiple choices here. But in the case, let's now compare. This is what we must have as the answer at the end. So let's see. Y equals to 2x plus 5 raised to power 5. If you have to solve this by using function of function is telling us that if you have uv, you want to differentiate uv, and this uv, they are both function of x, are both function of x. So what we are saying is that you have uv x and you have y equals to uv. You want to differentiate this. So what you do here is to say dy dx, because you are differentiating y with respect to this. Then that would be dy du times du dv times dv dx. Let's see, how are we going to resolve to this? And when you open it this way, you must have what you have on the left hand side. Du can cancel du, dv can cancel dv. So at the end you have dy over dx, and you have dy over dx, and this is what is known as function of function, which is known as chain rule. So if you are given this function and you have to differentiate y with respect to x, you must resolve into this. And when you resolve into this, at the end what you have on your left hand side must be equal to what you have on your right hand side. So let's use function of function to differentiate this. Y equals to 2x plus 5 raised to the power 5. Mind you, we must have this as our result. So let's confirm whether this is correct. Then when you are given this, the first thing you have to do is to say, let a particular variable be equal to what you have inside this bracket. Then that will be, let's say, let u to be equals to 2x plus 5. That's the first step. And see, when this u is now equals to 2x plus 5, then the whole of this becomes y equals to u raised to the power 5. Now we have two functions. That's why they call it function of function. We have u with respect to x. We have y with respect to u. So what are we doing? What is our interest? Our interest is to find dy dx. So the first situation, we have du dx and we have dy du. So what we are saying is that dy du multiplied by du dx, and du cancel du, you have dy dx, dy dx. So what are we going to do now? What we have to do now is differentiate this u with respect to x, differentiate y with respect to u, and your answer comes out